So first, let me give you a small introduction about what is a dynamic programming exactly. It's very simple one. Dynamic programming means what? It is just a method to solve the problems, to solve the problems by breaking simply, by breaking into smaller problems, smaller parts. One problem, we will just divide into multiple parts and storing that parts result, storing results to avoid solving same problem again, solving same problem again. See, so normally what we will do in some of the cases again and again in the problem, we are we are calculating that some part some part we are calculating again and again. So instead of calculating that same logic again and again, simply what we will do, we will break into some smaller parts. Once you calculate one time, suppose first time, store that result into somewhere. Next time, whenever you are trying to calculate that same part, instead of recalculating, already you have created that result for that part. Use that directly. Use that directly. Suppose if a problem repeats repeats the same calculations multiple times, simply dynamic programming helps to save the time. Helps to save the time. That is what simply. So what is that dynamic programming? What we do, that same calculations result, we store and use the answer whenever we want to reuse. We want to reuse. That is actually called dynamic programming main use. With examples, I'll explain. With examples, suppose I just want to display the best example to understand is a Fibonacci series is there. Fibonacci series. Right. After that, as some of the simple examples, we can do that, like a climbing stairs, they will ask. Next one is a coin change problems they will use. We'll see that one by one. I'll explain. First one is a simple example, is a Fibonacci series. But everywhere we use that recursive calling and all. We know that recursive calling. Simple one, without dynamic programming. Without dynamic programming, how can we do that? That printing Fibonacci series. Sir, I want to print only one. Like suppose is a f of 0 I want to print. Only one value. Okay. Directly print 0. Suppose if you are calculating that first one is a 0. So next one is a 1. But what about remaining? In recursion, whenever you are calculating, suppose f of n, always you need to perform addition operation with the previous one. Na? So f of n minus 1 plus f of n minus 2 we have to do. Nothing but calculating with all the previous values. Previous limit sum. See, suppose 0. is a 1. Please mute yourself. 0 plus 1, 1. 1 plus 1 is a 2. 1 plus 2 is a 3. 2 plus 3 is a 5. 3 plus 5 is a 8. Like this, actually, normally, Fibonacci series will go. Only one F0 means what is okay. Direct value we can do. So 1 is okay. But is a greater than 1 means what is a always calculating it is greater than or equal to 2. This is for simply that n value is greater than or equals to 2. From here, greater than or equal to 2. First to calculate this one. Next, these two calculate this one. Next, these two calculate this one. So how can we do this? In a normal program, recursively, how can we execute this one? And the same thing, suppose if you apply with the dynamic programming, how can we change? First is a normal recursion code I am writing. Normal recursion code. Suppose int Fibonacci series is a n. N. In this one is the same story. If n equal to 0, directly you return 0. That's it. 0. Suppose if n is equal to 1, in the series, nth element you are returning. Remember that. If n equal to 1, directly you are returning 1. 1. If not, it is returning Fibonacci series n minus 1 plus same Fibonacci series of n minus 2. This is the code I'm giving. Now, once again, I'm writing that Fibonacci series here. 0 is a 1, is a 1, 2, 1 plus 2, 3, 2 plus 3, 5, 3 plus 5, 8, 13, like this. Suppose I'm looking for 1, 2, 3, 4, 5, 6. Let us take a sixth Fibonacci number in the series. In the series, sixth Fibonacci number. So I'm calling, simply I'm printing just simply print off by calling that Fibonacci series and passing that value is a 6. That loop will repeat. How it is calling. First Fibonacci of n equals to 6. First condition fail. First condition fail. Second condition fail. Second condition fail. So return Fibonacci of n minus 1 plus Fibonacci of n minus 2. N minus 2. So both should execute now. Both should execute. Fibonacci 5 should execute. Fibonacci 4 should execute. It's the same code. Observe this. Now is a Fibonacci n equals to 5. Again, first two conditions fail. Directly written. Fibonacci of 5 means what? 4 plus Fibonacci of 3. Fibonacci of 3. Again, Fibonacci 3 should execute. Fibonacci 4 should execute. Again, in this one is a Fibonacci of n is equals to 4. N equals to 4. So return Fibonacci of 3 plus Fibonacci of 2. Again, 2 we execute. Now observe this. Is okay. Fibonacci 4 you calculate. Again, in the calculation of this Fibonacci 4, I'm writing this. Fibonacci 4 calculation. Again, what you are doing? Again, what you are doing? You are just returning. You are just returning Fibonacci of 3 plus Fibonacci of 2. Again, in these two, we are doing what? Again, Fibonacci of 3 function. Fibonacci of 3. In this one, what you are doing? You are returning, sorry, you are returning Fibonacci of 2 plus Fibonacci of 1. Here, Fibonacci 1 is will return 1. But again, here you need to calculate is a Fibonacci of 2. N equal to 2 means what? Here it is. You are returning that. You are returning that Fibonacci of 1 and Fibonacci of 0. There is a 1 and 0. 1 plus 0 value, 1 will come. The question is what? How many times you are calculating? Here 5 means what? Suppose Fibonacci 5 and 4 came. Fibonacci 5 and 4 came. Fibonacci 5 and 4 came. Suppose in these calculations, how many you are doing? Here again, two things. It will become what? It will become what? Directly I am writing 4 and 3 calculations. Here again doing what? 3 and 2 calculations. Here again doing what? 2 and 1 calculation. Here again doing what? 1 and 0 calculation. 1 and 0 calculation. Here also same 1 and 0. Here again 2 and 1. 2 and 1 calculation. Again here it is a 2. 1 and 0 calculation. This is for only 5. Again 4. Again for 4. Again for 4. For 4 and 3 calculation. And here it is for 4. 3 and 2 calculation. For 3. 2 and 1 calculation. How many times? Same calculations multiple times you are doing. Whenever you are going to find out that Fibonacci series, kth element in the Fibonacci series recursively. Same thing. How many times you are calculating? Suppose 2 is a 1 time, is a second time, is a third time, is a fourth time, is a fifth time. How many times you are calculating 3 is a 1 time, is a 2 times, is a 3 times, is a 4 times. How many times you are calculating 4? So why? Same problem solution you are calculating multiple times. You are calculating multiple times. So instead of that, whenever you want to calculate, first time whenever you calculate, keep that into one particular location. Is a take array. Take array, you just then easily we can find out. Easily we can find out. Suppose normally, how can we write the code? How can we write the code? It's a small change. It's a small change. Is it Fibonacci? Is a Fibonacci? Is the same n taking. It's the same story. If n equal to 0, you directly return. We can't change this one. Because directly, no need to see here, no need to put those values also. Return 0. Na? Suppose if n is equal to 1, n equal to 1 is a return 1. Return 1. and I'm creating one array. One array is any name. Suppose ARR or DP I'm giving, dynamic program. Is a new integer of, suppose n is there, n plus 1 I am giving. N plus 1 values I am taking. Size. First into DP of 0. Suppose if they ask the value 0. Sir, suppose into DP of 1 is a 1. But remaining. Simply I am writing the code like this. For integer I is equal to, starting from second location, I is less than or equal to up to that last location. What we are doing into dp of I into dp of I, what we are storing, previous values we are storing. What are the previous values? I minus 1 and I minus 2. I minus 1 and I minus 2. Two values we are storing. And simply returning what? dp of n. Now look at this. How easy the things will go. How easy. That array created is array created. Suppose if they have given what is the element you want. What is the element you want? Simply kth element. Here 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 we are taking like this. Simply we are taking like this. Is a 1. Now here, first into dp of 0, that 0 will go. Next into dp of 1 is a 1 will go. D from I is equal to 2. I minus 1 and I minus 2. 2 na? 2 minus 1 and 2 minus 2. 1 0 value 1. 1 1 2 3 5 8 13 22. Sorry, 21. Like this values will go. 32. It's like 53. Suppose. Now, whenever we ask, if you call that Fibonacci of 6 I am giving, it will go and store. So condition fail. Based on the given value, first array will be created. And according to that calculations happen. Finally, that sixth location element it will return. Sixth location. In sixth location, what is the element that will return directly? So before, instantly, instead of calculating repeatedly, instead of calculating through recursion, simply we are keeping that value. We are keeping that value into one array. And whenever they are looking for the value, directly we are displaying. Is a 1. Now, for example, if you take one more example, Simply, they have given like a climbing stairs. That is, For example, you are at the bottom of the staircase. N steps are there. N steps are there, and you are at the bottom of the staircase. You have an option. You can take, you can take either one step, or you can go with the two steps also at a time. Two steps also at a time. That is, then simply they can ask, just found how many ways you can reach, how many ways you can reach the top, how many ways you can reach the top. That is, for example, they have given simple input is a like any value 4 they have given 4. Then here it is an output is in how many ways means what? Let us take first each step we are taking one step, next again one step, next again one step, next again one step. This is one answer. Next one is a one step, then one step, then you take the two steps directly. This is the one. Next, like first one step, next two steps you take, then left only one step that you can take. No, sir, directly I will take a two steps first, then one step, then one step, then one step. Sir, why can't we take two steps directly? Yes, you can take two steps also directly. So for this one, here it is, your answer should come. Your answer should come, that is a 5. Because in 5 ways, you can stare 4 steps when you take either one step or two steps at a time. One step or two steps at a time. So that is, we can say that climbing stairs problem. That is what? Climbing stairs problem. That is the one. Okay. And the same thing is what? And the same thing is what? They can ask, like for example, is a coin change problem. Is a coin change problem. So what is that coin change problem? They will ask like this. For example, problem statement. Suppose you have some coins with some different values. Different values means what? It's like a 1 rupee coin is there, and a 2 rupees coin is there, and 5 rupees coin. You there, you there. Okay. So they will ask, suppose the total amount is a 5. You need to find out 5. In how many ways you can find out? It's the same story. Sir, all are 1 rupees coins only I will take. All are 1 rupees coins only I will take. Second option, the 1 rupees coins, 1, 1, 1. I will take a 2 rupees coin. Now see, you can't use a 1, 2, 1, 1 like a staircase. You can't use. Okay, you can use with like this 1 plus 2 plus 2. That is, or directly 5 rupees coin you can take. So your answer should come. Your answer should come is a 4. That is like the calculated amount, whatever the amount they provide with that specified values, the different coins with the specified values, how many ways we can do. That is, so that simple one is a dynamic programming means what? Repeatedly, some of the calculations you are doing in single problem if you do, same calculations multiple times, instead of doing, instead of doing, just store those values and use later on whenever you want to use. For that, main programs are, first they will ask a Fibonacci series. Next one, they will ask a staircase problem. Next one, they will ask a coin change problem. Same only. Just today we discussed only that Fibonacci series. I'll explain that staircase program also and coin change problem also. Okay.